Hi class, I'm just making this recording to post after class today because I'm going to just post the take-up of our linear and nonlinear functions investigation together. So you should have already done this in class. But what we're going to do is I'm just going to make this video so that you have access to, so that you have access to it after, in case you'd like to go back and just look at your investigation and what we did in class today. So we have our example. So it says, recall finite differences or differences between consecutive y values. Finite differences is also just the first differences, which we talked about today when we were doing our investigation from lesson 4. First differences. Consecutive y tables with evenly spaced out x coordinates. Right? So when you have something like -1, -2, 0, 1, 2, so there's only one point in between them, you can find the finite differences. So I'm going to just go in and I'm going to put in my x value here. So I have 3x, or sorry, -2. 3 times -2 is -6. -3, 0, 3, 6. So I'm just going to go here and I'm going to say, all right, what is -3 minus -6? And that's going to give me 3. 0 minus -3 is also 3. 3 minus 0 is 3. 6 minus 3 is 3. Right? So each time my difference between them is 3. I'm going to do the same thing here. So notice how the first differences here are constant. We're going to do a different type of function. We're going to do y to the x squared. So if I have -2 squared is going to give me +4. If I have -1 squared is going to give me 1. 0 squared is just 0, 1. And then 2 squared is 4. So let's go and find the finite differences here. 1 minus 4 is going to give me 3. This is going to give me, oops, not 0. 0 minus 1 is -1. 1 minus 0 is 1. 4 minus 1 is 3. Okay, so let's graph each of these. For the domain, y equals xer, which just means that this is a continuous function. Okay, so I'm just going to go in and I'm going to say, all right, I'm going to take my table value. So I have -2 and -6. So I'm just going to go down. -1 and -3. 0, 0. +1 and 3. So that's 2. This is 3. And then 2 and 6. And of course you're going to use a ruler, so yours will look nicer. But it's going to look something like this. Okay. Let's go point this one then. This one's different. We haven't actually seen this before, so this is kind of new. So we have -2 is at 4. Right? We have -1, and that's at 1. We have 0, 0 still. Then we have +1, and that's at 1. And we seem to be going back up. And that's at 4. And you have something that looks like this, right? When you connect them all together. That's a quadratic function, right? So you'll learn about these in grade 10, so don't worry about what this is. So it says, identify each of the following lines as linear or nonlinear. So this one's obviously linear, right? How about this one? Is it a line? No. So this is a nonlinear function. So let's try a few more. You have 2x here, right? So we're going to do y, -1. Oh, we have to find out the first. We have to find the y's, of course. So we have 2x. So we're going to do -2 times 2 is -4. -1 times 2 is -2. 0, 1 times 2, and then 2 times 2, right? Still going to go in, do my first differences. So -2 minus -4 is going to give me 2. 0 minus -2, 2. 2 minus 0, 2. 4 minus 2. Right? How about for this one? Let's see. So you have -2 squared, which will give me 4, plus 3, which will give me 7. -1 squared, which is just 1 plus 3, which will give me 4. 0 squared is just 0 plus 3. 1 squared is 1 plus 3 is 4. 2 squared is 4 plus 3 is 7. Right? First difference is 4 minus 7 is going to give me a negative 3. 3 minus 4 is going to give me a negative 1. 4 minus 3 will give me 1. 7 minus 4 will give me 3. Notice how these are not the same. And here, these are the same, right? And that's important. It's important for us to remember. Let's just go in and fill this chart out as well. We have negative 1, right? We want to change it into, we have negative 2 times 3 minus 1 will give me negative 7. Right, I'm just filling in my table of values using, plugging in my 1. Minus 1, negative 4. 3 times 0 is 0, minus 1 is negative 1. 3 times 1 is 3, minus 1 is 2. 2 times 3 is 6, minus 1 is 5. So let's just go in and put in our numbers. So we have negative 4 minus negative 7, 3. Negative 1 minus negative 4, 3. 2 minus negative 1, 3. 5 minus 2, 3. Right? Notice how, again, these first differences are constant. Important thing to remember. Y equals 2 to the power of x. So we're going to do y equals 2 to the power of x in this situation is 0. That's going to give me 1. Then we're going to do y to the power of 2x. So y equals 2 to the power of 1 equals 2. Y to the power of 2x, y to the power of 2 equals 4. Y to the power of 2x, y to the power of 2 to the power of 3 is equal to 8. And then lastly, y to the power of 2, y equals 2 to the power of 4. Oh my goodness, I'm struggling so much with my words today. 16, right? So let's just do the first differences. 2 minus 1, 1. 4 minus 2, 2. 8 minus 4, 4. 16 minus 8, 8. Notice how these are not constant. Important thing to remember. So it says plot the points for each relation in question 1. For linear relations, join the points with a straight line. For nonlinear relations, join the points in smooth curves. Use the domain y equals xer, which basically just means that it's a continuous function. Which of the 4 lines are linear? Which of the 4 are not linear? Right? I'm not going to plot them. I'm going to have you do that by yourself. But if you put in the plots, you'll notice that A and B, you'll notice that A is linear. Oh, that's strange. Sorry, guys. So you'll notice that A is linear. I'm just going to pause this. My mistake. So you'll notice that A in this situation is linear, right? Because it's y equals 2x. And notice that y equals 3x minus 1 is linear, right? So the 4 graphs are linear. What do the first differences in the relationship have in common? So I'm just going to go and write that in. The first differences in a linear relationship are always constant. Okay? How do the first differences of nonlinear differences differ from linear relationships? In nonlinear relationships, the first differences are not constant. Okay? Write a rule for the first differences to determine whether or not the relationship is linear or nonlinear. So if the first differences are the same, then that means it's a linear relationship. Write a rule determining from the equation whether or not they are linear or nonlinear. And this one I'm going to put in. If the exponent on the x variable is 1, the equation is linear, right? So what this basically means, if you had an equation like y equals 3x plus 4, because here there's no exponent, we assume it's 1. This is a linear relationship. If you had something like y equals 3x squared plus 4, because there's a square, this is nonlinear. And you'll talk about the type of equation this is. If you have something like y equals 2x, or let's just do 3x, y equals 3x plus 4, nonlinear. Because in this situation, the x is the exponent. And you'll talk about these later on in grade 11 and grade 10. All right? This is a quadratic, the x squared, and this is a exponential function. Alrighty. And that's it for this lesson. Take care. Bye.